separating your negative. So it would be negative 1 times square root of 49. Because it's multiplication, you can separate them. And we know that now that the square root of negative 1 is what? What's the letter? I. The square root of negative 1 is I. And what's the square root of 49? 7. So your answer is plus or minus 7i.
Confusing.
Why is it plus or minus?
Why is it plus or minus? Because when you take the square root of a number, you could have either had 2 negatives make that number or 2 positives make that number. All right, so again with the square root of 121, I can separate out my negative 1 from my 121, and I'm going to end up with I what?
11.
So my answer is?
Plus or minus 11i.
There we go.
This is so easy.
Don't say that.
Now, doesn't that make what was up top kind of make more sense when you actually apply it?
Yes.
Okay?
One question, I'm sorry.
Yes.
Okay. You said equal to I11, right?
Mhm.
Then you said equal to plus or minus 11i. Does it matter if you switch the number in the?
It's mathematically correct to, well, mathematically, I don't know,
It's normal.
nicely.
Mathematic-
I don't.
It's math etiquette.
Yeah, something to that
There's a
effect.
phone, there's a word.
To put the number before the imaginary.
Okay.
Just like 4x.
Yes. You're still putting your number before your variable. All right. Here, before you do anything, you have to simplify. Simplify means I simply combine my like terms. So what's 17 minus 42?
Negative 25.
So now I have negative 25. We should be able to do this without breaking it apart, right? So what should be my final answer?
5i.
5i.
Plus or minus
5i.
There we go.
So can we do that to all of them? Like all these first three?
But we went through the process so that you could see how to do it and what the ending result would be. All right, what about square root of negative 3? Is 3 a perfect square?
No.
No. So the only thing I can take out is the what?
Negative.
The negative, which is written like what? So all I can take out is the I, and I leave the 3. So it becomes plus or minus I square root of 3.
So you leave the 3?
Yes, because 3 is not a perfect square. So I can't take it out if it's not a perfect square.
You should put the music on. That was like Conjugate more.
All right? All right, let's go into the other side. Let's get a little harder. Okay? So on this side, we have 12 plus, guys, 12 plus the square root of negative 36 divided by 2. So the first thing I need to deal with is my negative. So when I take this apart, it's going to become 12 plus what?
6.
6 what?
6i.
6i over 2. Now you simplify by reducing. What can I reduce all these numbers by?
So you can say plus or minus 6i?
We're going to.
You divide them both by 2, so it's going to be 6 plus 3i.
There you go. So I can divide everything by 2, and this is going to become a,
6.
this is going to become a, and this becomes a 1. So my final answer is 6 plus or minus
3i.
3i.
I'm pretty sure I'm not. It's going to take me a while to get That's easy to me.
All right. Here, this is similar to which one?
Number 3.
The 3, because 5 is a,
It's not perfect square.
it's not a perfect square. So all I can take out is what?
The negative
The
is
I.
going to be equal to I negative 5. Square root of negative 5.
Because I can't do anything.
Plus or minus I square root of 5. That's what I just said.
All right, 180. 180 is a little different.
Wait.
180 is not a perfect square, but are there perfect squares in 180?
Yes.
Yes, I can do 9 and what? 9 times what gives me 180?
30.
30, yeah.
No,
20?
20.
Okay, I can do the square root of 9. What's the square root of 9?
3. 3.
3. So I already have an I out here. Now I'm going to put a 3. 9's gone. What does this break down to? 4 and...
times square. Yeah, 4 and 5.
Okay. What's the square root of 4?
2.
So now I have a 2 out here, but who's left inside?
5.
5 can't go nowhere.
Wait, what were we saying yesterday?
The ones that are left, you multiply them together.
Yeah. If you actually do the whole factor tree, I don't have enough room to do a full factor
the
tree.
one that there was like saying in Spanish now.
What's left inside, you multiply.
Okay.
Same thing.
All right, so you just multiply. 3 times 2 is
6.
I square root of, what did I forget?
Plus or minus 6.
No, I didn't.
Oh, plus or minus 6.
It's there,
Why
Trevor.
is it 6? Oh, okay, never mind. I see them.
Because 3 times 2 is?
I think you did the same thing as we used.
Okay, so let's recap this with what we did. All right, so we knew that it was a negative, right? So that negative underneath the square root told me I was going to have a I. So I went ahead and put my I. Now 180 is not a perfect square, but there are perfect squares inside of 180. So I factored out and I came up with square root of 9 and square root of 20. Because together they make square root of 180. Well, square root of 9 gave me 3. But square root of 20, is that a perfect square? No. So then it gave me 4 and 5. Square root of 4 gave me 2. And then can I do anything with the square root of 5? No. So it stayed inside. Okay? This is all multiplication on the outside. So it's I times 3 times 2. Combine my like terms, which is 3 and 2. And I end up with 6.
Do you have tissue?
Yep. See, senorita. All right, we have 45. It's a negative 45, so what's the first thing I know I can take out? I can come out. Arr.
Are they all going to be negative?
Yes, because we're doing imaginaries. Okay, so I took out my I. Now I'm focusing on the 45. So, what happens with 45? I can have a square root of 9 and a square root of... What's the square root of 9?
3.
Okay, so 3 comes outside. Can I do anything with the square root of 5?
No.
So it's going to just join it. And so my final answer is?
Plus or
3i.
minus.
3i times the square root of 5.
There we go. Okay, the reason why we're doing plus and minus now is because we're going into what the bottom part is talking about. The bottom part is talking about what's called a, these are complex numbers. Okay, so at the bottom part is saying complex numbers. And with the complex numbers, there's always a real part and an imaginary part. Okay, there's a real part and an imaginary part. When there's no a that's here, that means your real part is 0. When there's no a that exists, your real part is 0. So when I look at these functions, except for the 6, so here my real part would be a 0. My real part for 11i would be a 0. Real part for 5i would be a 0. But when I come over here, what's my real part for 6 plus 3i?
6.
It would be 6, right? Because 6 is my real value. It's the one that does not have an imaginary attached to it.
Oh, okay.
Okay? Do we get that?
Yes.
Okay.
Imaginary is I.
Imaginary is I. See the I and I?
So is it going to be always on the other side?
Mm-hmm.
Plus or minus?
Yes. So we either can say, when we say plus or minus, that means there's actually 2 answers. One answer is 6 plus 3i, and the other answer is 6 minus 3i. Okay, and what that's called, they're called conjugates of one another. And that's why you can simply put them together, because it's just the opposite of one another. And when we flip over our paper, we're going to talk about the conjugates. All right, so you should have flipped over your paper. And it wants us to write them in a plus bi form, and then identify the real and the imaginary parts. So on 25, how can I write that in a regular form? It's just 20.
Factor it first?
Huh?
Can you factor it first?
There's nothing to do.
Just 25.
So it would just be 25 plus 0i. Something is in my shirt. Probably hair. My hair fell down my shirt. Alright, so my real part is, ignoring Trevor, is, what's my real part?
25.
25. What's my imaginary part? 0i. You're not, buddy. Alright, 2. How can I write this into a problem?
0 plus 25i.
There we go.
0 and then 25i.
Beautiful. Alright. Do I have to do anything to this one?
No.
No. So I just have to identify the parts. What's my real part?
3.
What's my imaginary?
Negative
Negative
5i.
Thought I was going to get you. But you said the negative. No. Okay. Let's see.
Every time I was getting hard.
Alright, it gets harder. What do I need to do here? I need to simplify it first. So when I simplify this first, I'm going to end up with what? What's this?
9 plus square root negative 12. Oh, I mean, so I.
Over what?
9 over 6.
Can I reduce that?
Yes, you can divide by 3.
Because they're all divisible by
3.
3.
3 plus 4i.
So this is equals.
3 plus 4i over 2. You can still reduce. No, like.
7 over 2.
Alright. The reason why I wrote the 2 separately is when you're dividing 2 terms by the same number, that means that term is affecting each part. Okay? And because we were wanting to identify our real part and our imaginary part, I separated my denominator so that it's easier for us to identify our real and our imaginary. So what's my real?
3 over 2.
There you go.
And then it's going to be
What's my imaginary?
2i.
2. Oh, 2.
Because what's 4 divided by 2? 2. So that's why I separated this so you could see your real and your imaginary. Yes, you could have just written it as 3 plus 4i over 2, but would you have quickly told me what my real and imaginary were?
No.
I heard one yes.
Yes.
Okay.
C. Yes.
No.
Of course.
How do you say this one did just combine like terms?
Oh, oui. Yeah.
We.
All right. What do I need to do first?
Combine alike terms.
Combine the like terms. 3 minus 7 is? And then I have 5i plus 8i.
13i.
13i. Can I identify my real now?
Yes.
What is it?
Negative 4.
What's my imaginary?
13i.
So small.
Oh, snap, we got to do 40.
Oh, look at that. Nick said the F word. Foil. Duh. Duh. Alright, so we got a foil. So 6 times 6 is?
36.
6 times negative 2i is?
12i.
What kind of 12i?
Negative.
12i.
Positive 2i times 6 is?
Plus 12i.
Alright, let's see if you're going to get this one. 2i times negative 2i.
2i.
Oh, minus 4i squared.
Dang, Anna, you're smart.
She cheated. She's got the answer key right.
Okay, and then the 12 and then
Alright, what happened?
and then combine.
Why would it cancel out?
It
I
would.
mean, because it's
She not 36 minus 4i.
We are there. We're about to cancel out.
I'm thinking. Okay.
Alright, what does I square mean?
8. Just 2i.
Means 2 eyes. Right? 2 eyes.
Turn off your paper.
16i squared.
What does I square mean?
Negative 1.
Negative 1.
Turn off our paper.
Turn over your paper.
I said off?
I'm not
Yeah, you should turn
understanding.
off.
Okay. Alright, on the other side. I'm going, Trevor. What does I square equal?
Negative 1.
Negative 1. So when we see I square, we plug in a what?
Negative 1.
A negative 1.
Got it.
Got it? I square is
-1.
Priscilla's the only one that got it?
-1.
Yeah.
Okay, those are the only ones that got it?
-1.
All right.
What?
So what does this become?
40 plus 4.
Yeah.
It becomes 40. So therefore, what's my imaginary?
0 I.
0 I. So real part is?
40.
And my imaginary part is?
0 I.
We did it. We did it. We did it.
We ran up the mountain.
We weren't going that far. All right. So down here, what it's saying is that the conjugate of a complex number. Let me zoom out so I can read. So the conjugate of a complex number has the same real part but an opposite imaginary part. So when I say, I get my answer as 2 plus 3i, and I say, Trevor, what's my conjugate? You're going to tell me? Thank you. 2 minus 3i.
Opposite, right?
All right, it's the opposite imaginary part. Not the opposite real part, but the opposite imaginary. Okay? So,
Is that where it comes from?
huh?
You gonna drown in this?
Conjugate? Yeah. I'm gonna zoom back in. Is that good, Brittany? All right, so let's practice using the conjugate. So I have 25. What is the imaginary part?
0.
Okay, so what will be my conjugate?
Negative
25.
No, you gotta do the I part, right?
Okay, remember, the conjugate only affects the imaginary.
25 minus 0 I.
Which is just what?
25.
There we go. So my conjugate is just 25. All right, I have 25i. What is 25i written as?
0 plus 25i.
What?
And then it would be 0 minus 25i, which would be just
Negative.
25i.
Look at you.
Wait a minute.
Oh, you for real?
Huh? She was right. I will slow down and tell you why Priscilla was right. And she deserved to flip her hair. That's what she did after she gave me the answer. All right, so Priscilla told me that this 25i should become 0 plus 25i. Okay? That's because 0 is my real and 25i is my imaginary. And its conjugate only affects the imaginary. So it goes from being plus 25i to being minus 25i, which is just simply saying negative 25i.
Oh, we had 25.
Why is that? Why did you rewrite it over?
Huh?
Because that's how she said it. Why did you rewrite that over?
To identify the real.
Huh? Oh.
To identify the real.
So on the top one, you just did the same thing?
Yeah, I just added the imaginary.
You rewrote the 25?
Yeah, because I couldn't write a 0 over here. I didn't have any room.
Oh, so 0.
All right, Noe. What's my conjugate for negative 3 plus 6i? Mark, help Noe. What's my conjugate?
I know it.
That's not a good team. All right, Trevor. What's my conjugate?
Negative 6i.
Okay, so you did know.
What is it?
Say it again, Mark.
3 minus
Not 3.
Negative 3 minus 6i.
Okay, remember your conjugate only affects the imaginary. The conjugate only affects the imaginary. The conjugate only affects the imaginary. I think we got it. I think we got it.
I was behind. I was still filling in.
All right, I'll let you try again. What's the conjugate for negative 12 minus 5i, Noe?
No, you're sorry.
It's just you put plus negative plus.
Thank you.
Great job, Noe.
There you go.
Don't still try next time.
Yeah, don't steal my thunder next time.
Say something, please.
Is that a question or a statement?
Dixon should go like this when you talk. When you talk. So.
Huh?
Because it sounds like echo like that.
We need you to say this right.
Okay, anyways, what's the conjugate for 2/3 minus 1/5i?
2/3 plus 1/5i.
Look at them, they said it together.
Trevor.
Oh,
They said it together. Alright, last one.
5 minus
5 minus
1
square
square root of 3.
5 minus I square root of
3.
3. Alright, so let's recap conjugates. Conjugates.
Only affects the
Imaginary
imaginary
number.
number.
Conjugate of a complex number has the same real part as the opposite imaginary part.
Thank you for reading the definition also, Trevor. Alright.
Can
Okay.
you help us do like problem 1 on our?
I am, Priscilla, if you let me get there.
6, 7.
We're going to do number 1 together, and then I'm going to get you started on 8, 9, and 10. This class took a little longer than the last class, but I don't know why. Alright, number uno. First, when I simplify, this is going to become what?
Plus
Plus or minus 11i.
Okay.
Yeah. So we're paying.
We're just going to write the positive, because now we know our conjugate. So that negative part becomes our conjugate. That's 11i.
Oh, it looks like 16.
It does?
Yes, the board's kind of like,
Look like
you
a
need to see your
crooked.
board
You
again.
made your dot a little bit bigger than, but you ran your 11 with your eye. So
There you go.
Is that better?
Yes.
Do
fantastic.
they look separate?
Trevor had to get his answer right.
Yes, that's what I wanted to go over with you guys, okay? We were saying plus and minus because unknowingly you were already doing the conjugate. Ta-da! You didn't even know it, but you were. So, when you simplify, you usually start off with your positive, and when it asks for your conjugate, that's when you make it into the negative.
Who?
So you don't have to write the plus or minus.
Y'all
Why?
pay attention.
Why?
I was just behind.
Okay.
Why?
It's okay.
Alright, what's my real part?
You're leaving. Can you listen to this real fast? She said, Daddy.
Lottie.
What's my real part?
The real part is 0.
0. What's my imaginary?
11i.
Dang, I'm coming up.
Alright.
You said I was
Uh-huh.
paying attention.
Can I see it? Your hand's already on it.
Alright, I wanted to do 4 with you, so let's go to 4. On 4, it says a negative times the square root of a negative 16 over 49.
Is that a positive?
Okay, so let's talk about this one. So on this one, what's happening is I know that I have this negative on the inside. So how do I take that negative out? I put a what on the outside?
I.
An I.
Yeah, nah.
So now I have negative I, and on the inside I'm left with the square root of 16 over 49. So what's the square root of 16?
4.
And what's the square root of 49?
7.
Can you do the problem? I need to write it mathematically correct, guys. Negative 4 over 7i.
Who?
So what's my real part?
Negative. No.
0. What's my imaginary part?
Negative 4 over 7.
7i.
And what's my constant?
7i.
Look at y'all.
4 over 7.
Wait, just conjugate.
On simplify, it's just negative 56.
Really? We just.
On number 2,
If it's a negative, we make
under the
positive.
simplified, is it just like negative 56?
Yeah.
What's the conjugate of 4, 7, 9?
Alright, these are your hints for 8, 9, and 10. On 8, what you're doing is solving for 0, solving for x. So if I have 2x squared minus equals negative 50,
So you divide by 2.
I have to divide by 2 and then do what?
Then you got.
There you go. So you can finish it.
Oh, wait. Say that again.
Okay? On here, it wants you to solve for the following quadratic equations, right? Because all I have is one variable, I can solve it like a regular problem, right? So the way I solve it is, if I'm adding 50, the opposite would be to subtract 50. And all I have to do is work backwards to get what by itself. So instead of multiplying, I am,
Divide.
instead of squaring, I am
Square root.
square rooting.
So it's gonna be like a
Not 5. Not negative 5.
Describe it.
X minus 5.
You're gonna, yeah, finish.
X equals
I
5i.
think this is because you do.
X minus 5. X minus 5.
X equals
Cl-
5i.
Alright? Same thing here. Be careful though, you have to move the what first?
The 100.
You move the 8 and then you're gonna do what?
Just trying to get the 8 by
Something like
Let me
that.
add.
You gotta add it.
Okay, so I'm gonna add the 8 and then I'm gonna do what? Then I'm gonna divide by what?
-3.
And then I'm gonna do what?
Then you go square root.
There you go. Knew you could do it. Alright? Here's your hint for 10. It says, what is the quadratic equation with the solutions of plus or 7 minus? So it's telling me that my solutions were plus or minus 7i. Okay? When we talk about solutions, that means it came from what form?
Standard or virtual? No.
It came from factored form. My solutions came from a factored form. So if I came from factored form, what this is saying, I started off with and it wants you to find, what was that original equation? So what would you do to find that original equation? All right, you're on your own.
Can you come here for a second?
If you need to,
Let me read the thing.
oh, low C until my bad.
She looks into it.
Ask her about it. We got a question.
Yes. All right, guys, if you need to work on your notebook.